Hello friends, welcome to the basics of digital signal processing. In this session, we are going to understand the convolution sum. Now consider x of k be the input sequence, h of k is the impulse response of the system. Then the convolution sum is given by y of n is equal to summation k is equal to minus infinity to plus infinity x of k h of n minus k. So in this case, all these are in the time domain representation. See, the process of computing the convolution between the sequences x of k and h of k involves four steps. So first one, folding. Second, it is shifting. Third one, multiplication. And the fourth step is summation. So in the folding, so fold the sequence h of k about k is equal to 0. That is, with respect to origin, we are performing the folding operation. After that, we are going to get the sequence h of minus k. Shifting, shift h of minus k by n naught to the right if n naught is positive and to the left if n naught is negative to obtain the sequence h of n naught minus k. Then multiplication, multiply x of k by h of n naught minus k to obtain the product sequence given by x of k into h of n naught minus k. The last step is summation. Sum all the values of the product sequence v n naught of k to obtain the value of the output at the time n is equal to n naught. So in the further representation, we are going to consider this v n naught of k as y of n representation so that we can match that with the formula. Let us go through the problem for this one. The problem statement. The impulse response of a linear time invariant system is h of k is equal to 1, 2, 1 minus 1. Determine the response of the system to the input signal x of k is equal to 1, 2, 3, 4. So in both the sequences, first element itself is the origin, so that's why they are represented in common color. Coming to the solution, so the convolution sum is given by y of n is equal to summation k is equal to minus infinity to plus infinity x of k h of n minus k. Now in the first step, we are going to identify what is the output sequence length. In order to have that, we must have the length of the input sequences. Therefore, we are identifying length of x of k, that is 4. So 4 values are there. Therefore, the length is 4. Length of h of k, so that is also 4. Now the output sequence length is given by length of x plus length of h minus 1. So 4 plus 4 minus 1 is the values. So 7 is the answer for this one. Therefore, the n value will take the range from 0, 1 to dash 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 up to the 6. The same is the summation range, that is with respect to k, same range we are going to consider. Right? So remember, while making the summation range, we must be much clear about what is the origin in both h of k as well as x of k. So in this case, we are going to consider first element itself is the origin. Therefore, in this case, the summation will take the values from 0 to 6. That means total 6 values what we need to calculate. And in this case, since the first element itself is the origin, so it is going to take the summation range from 0 to 6. Right? Now, defining the convolution sum with respect to the given finite range. So we are going to have y of n is equal to summation k is equal to 0 to 6 x of k h of n minus k. Now first step, folding operation. So h of k is available. Identify h of minus k. So with respect to the origin over here, perform the folding element, folding operation. So all these three values, that is 2, 1, minus 1. So that will move to the another side of h of k. So that we call it as h of minus k. And this is what the representation we are going to get minus 1, 1, 2, 1. So whatever the value at the origin, that is not going to have any changes to that one. That will be always at the origin only. Now further solution. See, there are three different ways in which we can identify the solution for this one. So one is expanding the formula. Second one, this tabulation method. Third one is the graphical method. So in this session, we will be referring only to the tabular method and graphical method. Now getting into the tabular method of solution. So we will be making use of x of k and h of minus k and further representation. So here -3, -2, -1, dash dash dash, these are just position representations. So when we perform the folding operation of h of k to obtain h of minus k, then the position of this element -1 becomes -3. Therefore, we are starting the location from -3 and up to the positive, the length 6 we are going to take. So after making all shifts, what will be the position we are going to have? So that possible value we are going to represent in the sequence number. So this is the sequence number -3 up to 6 in a sequential manner. Then represent x of k. So x of k we have not we haven't changed anything in that one. So therefore at the origin the value is 1. So this is location 0, that's the origin, we are having the value 1, and at the location 1 we are having the value 2. So similarly we are having the further values over here. Right, now just for 1 or 2 I will be showing, remaining we can just make it out. Now h of 0 minus k we are going to have, that is same as the h of minus k. Now it is -1, 1, 2 and 1. So at the origin we are having the value 1, so that's what the same, and at location -1 we are having 2, at location -2 we are having 1, then at location -3 we are having the value -1, right? So as per the values we have got, same has been represented over here, -1, 1, 2 and 1. Now the values of x of k which overlaps on or which comes in the same column of h of 0 minus k, you multiply those values together. Multiply those values together. In this case only these two values are on the same column, that is 1 and 1, multiply them. So we are going to have the value 1. So no other values are on the same column with respect to x of k and h of 0 minus k. Therefore no further operations in this one. Now when it comes to the h of 1 minus k, so here this is going to represent 1 is the n0 value. N0 is a positive value. Therefore we are going to have a shift towards the right with respect to h of minus k, right? Therefore, so now it has got shifted one value, right? So here it is -1, 1, 2 and 1, right? Now x of k, the value 1, and x of 1 minus k's value 2, they comes under the same column. Now multiply them together. 1 into 2 is what the value 2 we have got. Similarly, in this particular location 1, so this 2 into 1, these two are in the same column. So 2 into 1, again 2, answer is equal to 4. Right? So similarly, h of 2 minus k in the sense, so shift the h of minus k by 2 values to the right, or with respect to its previous value h of 1 minus k, make one more shift over here. So we are going to get h of 2 minus k. So that has been done over here. Now at location 0 of x of k, it is 1 multiplied with this one, 2 multiplied with this 2, this 3 multiplied with this 1, right? So it is 1 plus 4 plus 3 we are going to have, answer is 8. So similarly we are going to move further until all the values of n0 has been completed. So we have taken that range from 0 to 6, n is equal to n0 if we make a consideration, then 0 to 6 is what is our consideration we have taken. Therefore for each shift we are going to have similar calculation, and finally we are going to get the answer over here, right? So now y of n is going to be the answer for this one, that is represented over here. And remember, Since in both the given sequences, origin is the first element itself, in the resultant also the first element itself is going to be the origin, right? Now getting into the graphical way of solution. So we need to have the h of minus k representation. So h of minus k, it is over here. The same is being represented graphically over here, right? Then x of k, it has been given for us, and we are going to have that representation over here, right? Now at n is equal to 0, we are going to have h of 0 minus k. What we have just gone through in the tabulation method, same thing graphically we are going to make the representation. H of 0 minus k, which is same as that as the h of minus k. Now multiply these two sequences position wise. See, at the origin it is 1, at origin here it is 1. So these 1 into 1 is multiplied. So no other values are being available to perform the multiplication. So all other values will be equal to 0. Therefore, only this 1 into 1, answer is 1, is what we are going to have. Similarly, when n becomes equal to 1, shift right the sequence by one value. So with respect to this h of minus k, one value has got shifted over here. Now perform the similar process of multiplication. At origin it is value 2 into this 1 we are going to perform. So that value is equal to 2. 1 into at the same location it is 2. Again answer is 2. So we have got this one. Now add these two values. 2 plus 2, we are going to perform the addition. Answer for this will be equal to 4. Right? Making the continuation at n is equal to 2. Again shifted right by one value. Again with respect to its previous representation. So x of k available. Perform the operation. So we are going to have answer as 8. So similarly it will be done for n is equal to 3. Same procedure. Further, n is equal to 4, same procedure. N is equal to 5, similar. N is equal to 6, similar. So finally, what we have done in the tabular method, same answer we are going to get over here as a part and parcel of the graphical procedure. Thanks for watching.